The vast majority of shapes you're going to see on the SAT are going to be either triangles, quadrilaterals, or triangles, or some weird Frankenstein combination of those shapes. Though occasionally we will see, or at least be described, polygons with more than 4 sides. And the major 3 you're going to see, if you do see them at all, are going to be the pentagon, which is 5 sides, the hexagon, which is 6, and the octagon, which is 8. And that's about as far as it could go. They're not really big on any other weirdo shapes besides those. Now, in terms of definitions, one definition to know is what a regular polygon is. And a regular polygon is basically a polygon with equal sides and angles. So you could talk about a regular pentagon, a regular hexagon. A regular quadrilateral, well, that's just a square, so we don't really call it a regular quadrilateral. And a regular triangle is just an equilateral triangle. So you're already familiar with this. It's just when we get into the stranger shapes, we sometimes use these words. The 2 things you need to know, maybe, this doesn't come up much at all, for polygons is first is the sum of the angles in those polygons. So we already talked about that a triangle, the angles add up to 180. And in any quadrilateral, the angles add up to 360. What about for a pentagon? Well, the way to think about this is look at the quadrilateral. Notice I can cut this into 2 triangles. So since this is made up of 2 triangles, 2 times 180 is 360. Notice I can take this pentagon and cut it into 3 triangles. 1, 2, 3. So each triangle's got 180. 3 times 180 is 540. I can do this with a hexagon. So here's my hexagon. I can go ahead and cut this into 4 triangles. 1, 2, 3, 4. Each triangle has got angles adding up to 180. So 4 times 180 is 720. And so on, right? I can go, arbitrarily many sides. I could draw the shape and figure out how many triangles there are. There's a formula for this, though. So for some n-sided polygon, so a polygon with n sides, the formula, the number of degrees, or the sum of the angles in the polygon is equal to 180 times n minus 2, where again, n is the number of sides. And this makes sense, right? Imagine for a 3-sided figure, we plug that in for n. We get 3 minus 2 is 1, which is 1 times 180 is 180. Notice the n, when it's 4, in this case, gives us 2 in here, and this is really, n minus 2 is the number of triangles in the shape. Again, you just need to know this, or you can remember the pattern, either way. And finally, it just doesn't come up that much. One last thing, which really doesn't come up much, but it is within the realm of possibility for them to ask about, it's the measure of one angle in an n-sided regular polygon. So if I have, say, a hexagon, and I already figured out that it has 720 degrees total in these angles. If this is a regular polygon, all these angles are the same. So how do I find the measure of just one of them? Well, I've got 6 angles, 6 sides, 6 angles. So I just divide my 720 by 6, and I get 120 degrees. So for any arbitrary polygon, if we wanted to know the number of degrees in an angle of a regular polygon, it would just be the total number of degrees in that polygon, which we already figured out is 180 times n minus 2, divided by n, right? Divided by the number of sides, aka the number of angles. That will give us how many degrees are in each angle. So again, these are 2 formulas that aren't up front. They don't come up much at all, but if you want to get an 800, for instance, they're definitely something you want to have just in case they do ask these kinds of questions.